Good morning, Mr. Herman here with our last video on our Unit 2 trigonometry notes. So what we're doing here is we're looking at trigonometry in context. So we've worked on inverse trig, we've worked on trig, we've looked at the Pythagorean theorem, finding missing angles, and now we're going to put it all together like we did before with solving right triangles, but now we're going to take a look at this in context. So before we get started in context, we need to look at a couple of vocabulary words. One of them is angle of elevation, and that's going to be the angle created by looking up a triangle. Okay, so it's going to be something like, here's a triangle, it's this angle right here. Now, we also have something that we call the angle of depression. And this is the angle created by looking down a triangle. And that's to be that angle right there. Okay? So we'll be drawing some pictures, looking at some pictures today, so it should be clear kind of what's going on, what angle we're trying to find, but we want to make sure that we're familiar with those terms. So with trig in a context, always draw and label a picture. Always draw and label a picture first. Second, solve like a normal trig problem. Okay, I want to solve like a normal trig problem. So the only difference here is that we have to make sure that we know what everything represents in our problem. So look at a few where the triangles are already drawn for us. We'll look at a few where we're going to draw and label the triangles ourselves. And then we'll have a little bit of practice as well. So let's look at number one here. If your distance from the foot of a tower is 20 meters and the angle of elevation is 40 degrees, find the height of the tower. So here's we are 20 meters from the base of the tower, the foot of the tower. So here's our 20 meters. And then our angle of elevation, so we're looking up our triangle, so it's going to be this angle right here. And we want to find the height. So I'm going to call this H for height. So let's label our triangle. We're going to solve like a basic trig problem now. So we've got our angle of our reference angle here, across our triangle, or opposite. We've got our side that's between our right angle here and our reference angle, so there's our adjacent side. And if I think opposite over adjacent, what trig function is that? Hopefully you said tangent. So let's go and set it up. So tangent, since I'm looking for a side, I'm going to use normal trig. So tangent of 40 degrees equals my opposite side, which we called H, over my adjacent side that we called 20. We multiply by 20 on both sides to get that out of my denominator. So 20 tangent 40, its H is going to be about 16.8, and I want to put my units on there. Okay, so that's another change in our context. I'm going to make sure that we can draw the picture and label it, like our context will say, and then also put our units on our response. Let's go and look at our second problem here. So we have a ramp with an angle of inclination, another fancy word for elevation, of 20 degrees. It has a vertical height of 1.8 meters. What is the length, L, in meters of the ramp? Okay, so we're trying to find this length up here, L. So we have our angle here. There's our reference angle of 20 degrees. The vertical height, so this is going to be our opposite side, or across the triangle. This is where our right angle would be, and then across from the right angle is our hypotenuse. this case, we'll call it L. So if I'm thinking of opposite over hypotenuse, that should be what function? My sine function. So let's go ahead and work that problem out. So I have sine of my angle, my reference angle, 20 degrees, equals sine is opposite, which is 1.8, over my hypotenuse, which we said is big L. Okay, use our little trick. That denominator switches positions with my left-hand side. And then put that in the calculator. L is going to be about 5.3 meters. Okay, so we labeled our picture that we were given, and we put our units on our response, but everything else just looks exactly like a regular trig problem that we've done before. So let's look at a couple others. We've used normal trig there. We're going to use maybe some inverse trig somewhere. I don't know. It could come up here. So let's look at this one. We've got a flagpole that is 45 feet high and casts a shadow. Here's our flagpole. Here's our shadow that is 52 feet long. What is the angle of elevation, A, of the sun? Okay, so here we go. Here's our angle of elevation because we're looking up our triangle. Now reference angle, we've got opposite side. We've got between the reference angle and the right angle, here's our adjacent side. And if we see opposite over adjacent, what trig function? Tangent. Now, we're solving for an angle. I'm going to pull up the notes from the other day when we went through our little chart. We have a missing angle. We have two sides. We want to use arcsine, cosine, or tangent. So, since we have tangent here, let's use arctangent. So arctan, what's our ratio? Opposite, 45. Adjacent, 52, equals A. We put that in the calculator. Let's put that in the calculator here. So remember, we got to think about, after our blue button, the second, and then tangent to get the inverse tan, and then 45 divided by 52. 40.9 degrees. Okay, make sure you put that degree symbol on there. All right, so now we've got a little situation where we don't have a picture. So we got to draw a picture. So let's see what's going on here. We've got the top of a lighthouse is 160 feet above sea level. Okay. The angle of depression to a boat at sea is 25 degrees. So this angle of depression, that means that we're going to be looking down at 25 degrees. And we want the horizontal distance. So that's the length that we don't know, from the boat to the base of the lighthouse. So here's our lighthouse. Okay. And we know that, and then here's our boat. Let's draw a boat. Okay. I'm in the Art Design Communication Academy. There's my art. So we know that the lighthouse is 160 meters, or feet rather. So here's our C, 160 meters, or feet. Oh. We want to know the horizontal distance. So this length right here. And we know we have the angle of depression. So we're looking down the triangle at 25 degrees. Okay? So let's go ahead and label our sides. Reference angle, So here's what's opposite my triangle, or my reference angle. Here's what's adjacent to my reference angle. Opposite over adjacent equals tangent. We're finding a missing side length, so we can use regular trig here. So we can do tangent 25 degrees equals my opposite side, which is 160. My horizontal distance is my adjacent side, which is x. Flip my denominator and right side. So the next is going to be about 343.1 feet. All right, so we got one last problem here. We're looking at some triggering context. We've got federal accessibility standards specify that a ramp used for a wheelchair ramp must be less than or equal to 4.78 degrees. The length of one ramp is 14 feet and its vertical rise is 1.2 feet. What is the ramp's horizontal distance and its ramp angle? So here's our base. We don't know this length. We're going to call it x. We make a ramp here. We're told that its vertical rise is 1.2. And we're told that the ramp length is going to be 16. And we know that our reference angle is right here. We call this theta. Use that theta here. Okay? So let's start with let's find the angle first. Okay? So if I have my angle right here, there's my opposite side. Across from my right angle is my hypotenuse side. Opposite over hypotenuse. This should be memorized for us hopefully by this point. Opposite over hypotenuse is going to give us sine function. Now we have a missing angle here, so I want to use my arc sine. My ratio of 1.2 is my opposite side over 16, my hypotenuse side, equals theta. I put that in the calculator, and I get theta is 4.3 degrees. Okay? So 4.3 degrees. So does it meet the federal accessibility standards? Yes. Because 4.3 degrees is less than 4.78 degrees. Now we still need to find x. Now we can take several approaches here. If we think back to our chart the other day, we've got a missing side. We have two sides. We could Pythagorean theorem it, but we also have a side and an angle. So we could do sine, cosine, or tangent. I'm feeling some Pythagorean theorem this morning. So we've got A, B, and C. So x squared plus 1.2 squared equals 16 squared. We'll do some calculator action. Ooh, we had a little technical difficulty there. So we got x squared plus 1.44 equals 256. Let's do some subtraction to get that x squared by itself. So 254.56. And since we have the x squared by itself, we can go ahead and square root both sides, and x is going to give us approximately 15.95. So that would be the horizontal rise of our ramp. Okay, so let's take a little time to work on some of the practice problems to make sure that we can use our trig in context.